Hey there everyone, welcome to Sources classes. In this video, we are going to discuss about the golden age of John Robinson's model, right? So, to start with, let us discuss about the assumption of this model, okay? So, first of all, it is a closed economy, that is, there is no foreign trade, right? So, it is only consumption, investment, and government sector that we are talking about. Second is there is no technological progress, okay? Then the fixed production is fixed coefficient of production, and also there is no government intervention. So the first one, there is closed economy, means no trade with no government intervention as well. So it is only consumption and investment we are talking about, and only two factors of production, that is labor and capital, right? Now what are the additional assumptions here? Number one is, here we have considered only two classes, that is the workers and the capitals, okay, among whom the national income is distributed, okay. Next assumption is worker saves nothing, that is whatever their wages they will completely spend it, right? Then, and also capital also consumes nothing but save and invest their entire income, okay. So whatever the profit of the capitalist is invested, whatever the income of the consumer is, that is spent, right? So there is no change in price level, and savings is a function of profit here, right? So because of a profit, there will be savings which will lead to investment. So that is how the assumptions are made. Now let us determine the growth determinants here. First one is thriftness condition. Thriftness condition means, we know that individual savings leads to decrease in aggregate savings, okay. So that is thriftness condition, means people tends to save more by consuming less. That is the tendency. Thriftness means কিপটামো যেটাকে আমরা বাংলায় বলি, right? So that is thriftness, or the पैसे खर्च नहीं करना, that is called thriftness. Second one is technological conditions, so number and quality of labor and its growth and technical knowledge. Third one is wage bargain, right? So that is the determination of money wage. The market structure here is not necessarily a perfectly competitive market. Talking about investment, it is completely decided by the firms. And last one is finance. The financial institutions and rate of interest and money policy are all related under this category. Now let us quickly move to the model. Let us see what this model is about, right? So for the income point of view, right, let the national income is denoted by Y, and we know that Y is the function of here, since we have labor, so that is wage, and for capital, that is the firm, that is the total profit, right? That is our pi. So W is the wage and pi is the profit. Together is our income, which is distributed between the labor and the capital, as we have assumed in the assumptions of the model. Now P is the average price. So let us divide it using the following, that is W by P into N plus pi into K. So from here we get pi K is equals to Y minus W by P N. Okay, so what is this? Basically this is total income. Now this is for one individual. Now if there are n workers, n laborers, and if W is the nominal wage rate, then W by P is the real wage rate. So total, if there are n laborers, then Wn by P is the total income of the labor. So that is W by Pn. And similarly, if one unit earns pi profit, then K capital will earn pi into K profit. So this is our total income. Now from here, pi into K is equals to income minus the real wage of the labor. So we can determine here that the profit is equals to basically Y, that is the national income, minus the real wage of the worker, that is the real wage of the worker, divided by the total capital. Now we can divide this numerator and denominator with n. We get Y by N minus W by P. N and N gets cancelled, and K by N. Now Y by N is denoted as rho. W by P is our real wage rate, and K by N is our theta. So what is rho and theta? So rho is labor productivity, that is Y by N, that is total income per unit labor. So that is labor productivity, and theta is capital labor ratio, that is number of capital K divided by number of labor N. So therefore, the profit is determined by the labor productivity minus the real wage divided by the capital labor ratio. So the above equation indicates that profit rate, that is pi, is a function of labor productivity and real wage rate and capital labor ratio. That means pi, that is the profit, depends on rho. Rho is our labor productivity, W by P is our real wage rate, and theta is our capital labor ratio. So these are the three determinants that derive the profit of the firm, right? That is the profit rate. So this is the income point of view of the model. Now let us have a look at the expenditure point of view, right? So from the expenditure point of view, so we know there are only two sector here, that is household and farm. So the total income from the expenditure point of view is C plus I, right? That is consumption expenditure of the household and investment expenditure of farm. Now at equilibrium, we know that savings is equals to investment, right? Now, in this model, where wage earners spend all their wages on consumption while profit takers save and invest all the profit income, that is what can we write? S, that is savings, is basically profit into capital, and which is your investment. Since savings means your total investment, and which is equals to the total profit on the capital, right, that is invested. So that is why S is equals to total profit on the capital, that is pi into k, which is invested, so that is I. And we also know investment is change in capital, so I is equals to delta k. So from these two equations, that is this equation and this equation, what can I write? I can write that pi k, this is pi k, is equals to I means delta k. So this is delta k, that is this, that is pi k is equals to delta k. So from here I get pi is equals to delta k by k, that is the growth of capital, right, which is equals to small k, right? So that is the rate of capital accumulation. So what is this small k? This is rate of capital accumulation, right? Now let us have a look at the condition in order to get the equilibrium. So for the equilibrium, we have to compare the income and the expenditure side. So let's go up and check our income side of the model. So from the income side of the model, we have derived this. This is the profit rate, right? That is rho minus W by P by theta, right? This is your income side. And just now we have checked this pi is equals to small k, that is the capital accumulation. This is our expenditure side. So this is equals to this is the point of equilibrium, that is income is exactly equals to expenditure. So we are going to put this value in order to find out the equilibrium condition. So the equilibrium condition is pi is equals to, from the income side, that is rho minus W by P by theta, is equals to from the expenditure side, that is small k, that is your capital accumulation, right? So that is, for the economy to be in equilibrium, the rate of profit must be equal to the rate of capital accumulation, that is small k. So this is the condition for the equilibrium in the Joan Robinson's model, right? So that is the rate of profit is equal to rate of capital accumulation at the point of equilibrium, right? Now there is a double-sided relation between the rate of profit pi and the capital accumulation small k, that is pi and k. That is what, on one hand, it tells us that k is going on in a particular situation determines the level of profit obtainable therefrom. On the other hand, the equilibrium condition shows that pi itself governs the rate of accumulation. That means they are interrelated. K determines pi and pi determines k. That is, if there is capital, if there is profit, then there will be great capital accumulation, and if there is capital accumulation, then there will be profit earned. That means if there is no profit, there will be no capital accumulation. As a result, there will be no profit further. So this is related in a cyclical manner, right? Circular way. So this is a circular relation of the rate of profit and the rate of capital accumulation in the Robinson's model. So here is the conclusive line for the equilibrium, that if they have no profit, the entrepreneurs cannot accumulate, and if they do not accumulate, they have no profit. So you need profit for capital accumulation and you need capital accumulation for profit. So profit, pi, and capital accumulation k are related in a circular way. Now let us look at the golden age rule of John Robinson's model, right? So the situation of smooth steady growth with full employment arising out the equality of the desired and possible rate of accumulation has been designated by Mrs. Robinson and the golden age equilibrium. Now suppose theta is constant under the condition of full employment. Okay, so what is the condition of full employment? Is basically your capital to the labor ratio is equals to theta, as we have written earlier. From the income expenditure side, we have denoted theta as the capital labor ratio. So here is the capital labor ratio. So that means labor is equals to capital by theta. Now any change in n should be equal to change in capital with respect to theta. Now in order to show the change, what we have done is we have divided n on both sides, that is delta n by n is equal to delta k by theta by n, right? Now what we have done here is n is equals to k by theta, so in place of this n we have substituted k by theta. So that is change in labor or the rate of labor is equals to delta k by theta by k by theta. Obviously this theta and theta gets cancelled, so in we have uh, delta n by n, that is the labor growth rate, is equals to capital growth rate, right? So this implies that if capital labor ratio is constant, right, at the full employment level, then labor and capital grow at the same rate. And this is our golden age equilibrium, where it says that the if the capital to labor ratio is constant, that means both of them are growing at the same rate, and that is why the ratio is constant, right? So whenever the labor rate of growth and the capital rate of growth is equal in the at the point of equilibrium with full employment and constant theta, then we reach this equilibrium condition, and this situation is our golden age equilibrium of John Robinson's model, right? So this equality between the desired and the possible rate of accumulation coexists with full employment of labor and capital, right? So the economy is thus on a steady growth path. A steady rate of accumulation then rolls smoothly on its way. There is a harmony in all respects. So this is our golden age equilibrium of John Robinson's model.